Well, my dear student friends, in this video lecture I am going to discuss about that first unit, that is conservation laws. Okay, in the physics we often deal with the conservation principles because most of the physical properties abide by the conservation laws, especially conservation of energy, conservation of linear momentum, conservation of angular momentum, conservation of charges. Okay. So, here and in a generalized, what is the conservation law? That is a generalized definition of the what is the conservation law? Actually, conservation law definition in a generally, that is a conservation law states that a particular measurable property of an isolated system does not change as a system evolves. Okay, means conservation law states that a particular measurable property, that measurable property is what? That may be energy, that may be momentum, angular momentum or linear momentum or charge. Okay, that is a measurable property. Measurable property of an isolated system does not change as a system evolves. I hope you have already studied about the law of conservation of energy. That is the energy neither be created nor be destroyed, and it transfer from one form to the another form, that you have already known. So, in other words, we can say it as a total energy of an isolated system. Total energy of an isolated system remains constant and is said to be conserved, right? And this law of conservation of energy is an empirical law of the physics. We have to call it as an empirical law of the physics, means it is a verified law of the physics. And now, so we have already law of conservation of energy. Then what is the use of law of conservation of linear momentum, angular momentum? Okay, why it is necessary? Is it required? Yes, because this law of conservation of energy, it has some limitations, means conservation law of energy fails to provide the complete and satisfactory solution to the problems involving in the interacting body. Okay, if the body interacting with the other body, then it fails to provide the satisfactory results of that problem. Okay, and this is all about the conservation laws. And here, so then if it fails, then how we have to solve these problems? With using the law of conservation of linear momentum, law of conservation of angular momentum. As per your syllabus, this conservation law includes law of law of conservation of linear momentum and law of conservation of angular momentum. That remaining we will discuss later, right? So, first one, actually how it fails this energy give the satisfactory results. For example, if I fire the bullet from the gun, okay, that bullet will move in the forward direction and it has a kinetic energy, and also the gun, it will move in the backward direction, right? So, here and again there is a production of the kinetic energy, and also sound will also arises, that is a sound energy, and heat will also comes. So, heat energy. So, there is a distribution of energy. Actually, we can't get how the energy is distributed in the gun and in the bullet and in the atmosphere. So, to solve that type of problems, the law of conservation of momentum, that will give the satisfactory solution to the problems involving in the interacting bodies, right. So, now the law of conservation of linear momentum and angular momentum. Right. First, okay, right. Usually body have the two types of motion. One is a linear or translatory motion, or another one is a rotational motion. Okay. Usually linear motion means the body which is moving in the straight line path, right, and rotational motion means it is with a fixed point it is revolving in a particular orbit. That is rotational motion we have to call it as. Okay. Now, usually the momentum is again bifurcated into two types. One is a linear momentum. First one is depends upon the motion, linear momentum, and second one angular momentum, right. So, if the body has the linear motion, it contains the linear momentum. If the body is in a rotatory motion, then we have to call it as a angular momentum, right. Now, we will discuss about the first one by one. We are going to discuss, that is the linear momentum. What it mean? What is the linear momentum? That we will discuss now. Cut. Okay. Now, we will discuss about the linear momentum, and it is a common experience that a moving body has a capacity to impact the motion to those bodies with which it collides. For example, I am the moving body. If I collide with the another person, okay, then that motion will impact on the other person, right. So, that impact is depends upon the what? That impact is depends upon the my mass and velocity. Okay. If I am slowly moving, okay, then a person is standing there. Okay. If I collide with him, the impact is less. Okay. If I am moving with a speed, means my velocity is more than if he is standing. If I collide with him, then there is a impact of the motion. Means that impact of the motion is depends upon what? Depends upon the mass and depends upon the velocity. Let us take one more example. For example, one person is traveling on a bicycle, right. One person is traveling on the bicycle and another person is traveling in a car. Right. And these both persons, the person moving in the car and one person is moving on a bicycle, and its mass is different and its mass is different. Here the mass of this body m1 is less than the m2, and the velocity of this bicycle is v and velocity of this car is also v, and both have the same velocity moving in a opposite direction. Okay. If this both bicycle and car collide with each other, what is going to happen? Definitely accident, right. So, if accident happens, the impact more on whom? On car or on bicycle? Definitely bicycle. Maybe you have observed in our day to day life, even ಯಾರಾದರೂ ಬೈಕ್ ಮೇಲೆ ಹೋಗುವಾಗ ಟ್ರಕ್ನವ ಏನಾದರೂ ಇನ್ ಕೇಸ್ ಬೈಕ್ನ ಒಂದು ಮಿಸ್ಟೇಕ್ ಇತ್ತಂದ್ರೂ ನಾವು ಯಾರ ಮ್ಯಾಗ ಬ್ಲೇಮ್ ಯಾರು ಮಾಡ್ತೀವಿ? ಟ್ರಕ್ನ ಒಂದು ಮಿಸ್ಟೇಕ್ ಇರ್ಬೋದು ಅಂತ ಮಾಡ್ತಿರ್ತೀವಲ್ಲ. ಸೊ ಸಿಮಿಲರ್ಲಿ ದಟ್ ಈಸ್ it is a quite common thing because that is a bigger body. So, this is a smaller one. So, of course, there is a mistake, but according to the linear momentum, the impact of the motion is depends upon the mass and depends upon the velocity. Here both have the same velocity, but impact on the after the collision, the impact is more on the bicycle rather than the car. Why? Because its mass is less and its mass is more, because it has a more linear momentum, it has a less linear momentum, and the linear momentum of this body is greater than the linear momentum of bicycle. Similarly, I am going to take one more example. In spite of bicycle, I am going to take one more car. Right. So, and this car has a same mass, both have the same mass, but velocity is different. Okay. Here the velocity of this body v1 is greater than the v2. Okay. Velocity of this car is greater than the velocity of this car. So, if both cars collide each other, so the impact on which body, M1 or M2, means sorry, on this car, first car or second car, definitely the impact is more on the first car, because it has a more momentum, means it has a more velocity and it has a less velocity. Means the conclusion is what? Here the momentum is depends upon the mass of the body and velocity of the body. That is, we have to, in generally, actually the linear momentum is denoted by P. Mathematically, that linear momentum, it is the product of mass and velocity. So, P is equal to m into v, and here that linear momentum is a vector quantity, and the SI unit of linear momentum, that is, m means kg, velocity means meter per second. The SI unit of linear momentum is kg meter per second. And second one, the dimensional formulae, that is m L t raised to minus 1. This is a dimensional formula of linear momentum, right? In the next class we will discuss about the law of conservation of linear momentum. This is all about the introductory part of the conservation law. In that we have already discussed about the generalized law of conservation of momentum, generalized conservation law, and law of, that is a linear momentum, and just I have given the another one, that is the law of conservation of energy, and that is a linear momentum, just I have discussed, and about the angular momentum we will discuss in the next continued part. In the next session we will discuss about the law of conservation of linear momentum. Thank you.